Hello everyone, myself Yadagiri, Assistant Professor, Department of EEE, MLR Institute of Technology, Hyderabad, and I am also the Faculty of Basic Electrical Engineering. In the last session, we have discussed about the numerical based on the three-phase AC circuits, which means the three-phase AC circuits means under the star and balanced delta network. So in the last session, we have discussed about the problem based on the three-phase balanced star connected and also the delta connected network. So in that, we have discussed about the line and phase voltages and also the line and phase current relationships. So based on that also we have discussed the numericals on the line and phase voltage and currents of the balanced delta and also the star connected system. So it is a new model of the session, that is a transformer. I mean, in this session we are going to discuss about the new module or new unit, that is a single transformer. So in the transformer we have the two kinds of transformers are there. One is a three-phase transformer, another one is a single-phase transformer. So usually this one is a commercial applications, and usually this one is a both commercial and also the domestic applications. So in this session we are only discussing about the single-phase transformer, because in BEE curriculum we are going to discuss about, according to the BEE curriculum we need to discuss about the only single-phase transformer. So for that we need to start the session. So first, the overview of the session is, so this is the overview of this today's session. So in this session, we are going to dealing about the introduction details of the single phase transformer. Then after that, we will go to the construction details. First of all, what does it mean by transformer? What kind of usage is there for the transformer, and also the how the construction is going to design. I mean, based on that, how would you like to discuss about the parts of transformer? And after that, what's the working principle behind the transformer? That's why, so we need to discuss the working principle of the transformer. So these three things we need to cover in this session. So let's begin the session. The first one, introduction to transformer. So the transformer is a static device which is used to transfer the electrical power from the one circuit to another circuit without changing frequency. So without changing frequency in the magnetic material or the magnetic media. So it used to transfer the electrical power from the one circuit to another circuit. In simple words, in the simple terminology, the transformer is used for enhancing the voltage levels, and also the decrease the voltage level, enhancing and as well as the decrease the voltage level based on the requirement. If you are able to decrease the voltage level, so that will take care of transformer only based on the requirement. If you are able to increase the voltage level based on the requirement, again we can use the transformer to increase the voltage levels. So that's what we have to use the transformer in everywhere. So the best example, communication applications and also the all kinds of electrical applications, etc. So these are the introduction. I mean, so it is a static device which transfers the electrical power or electrical energy from the one side to another side or one circuit to another circuit. So without changing frequency. So in the magnetic media only, it's happening from the one circuit to another circuit. I mean, it has transfer the power from the one circuit to another circuit. So this is called as transformer. So the transformer has mainly two parts that we need to discuss in the construction details. So now we will go through directly the construction details of the transformer. So previously we have discussed the introduction about the transformer. So transformer is a static device, so which is used to transforms the electrical power from one circuit to another circuit without changing frequency. So if you are able to make the frequency changes from this circuit to this circuit, the entire power system is going to collapse. Why? Because this kind of frequency changes can't accept the loads. We have the loads already designed for the certain ranges, I mean certain standards. So based on that, it can't withstand that frequency. So for that reason, so if you are able to make the sudden changes towards the frequency of the transformer from primary to secondary, the entire system is going to collapse. Because this is I mean load side we can consider. So this load is also connected to all other loads. So if you are able to get some kind of abnormal condition in this side, then it will interconnect to other one means. So the entire system is going to get collapsed. That's the reason why we can't get the changes in the frequency from the primary to secondary. So that's what we can say without changing frequency. So it was only the transferring the power from the one circuit to another circuit in the magnetic media only. So that's what in the magnetic media. So it used to enhancing the power levels and also decrease the power level. So that's what it is, a static device then which used to transform the electrical power from one circuit to another circuit. So static, how does the static means? It doesn't have any rotating part or moving part like a machine. So that's what we can say, it's a static electrical device. So finally, what I want to say means, so transformer is a static device which is used to transform the electrical power from one circuit to another circuit without changing frequency in the magnetic media. So based on the requirement, it used to enhance the voltage level and as well as decrease the voltage level. So that's what we have to use the transformer. So this is the introduction about the transformer. Then let us move for the construction details. The construction details of transformer, we have mainly two parts are there. So that is the transformer winding and as well as the transformer core. The transformer core is a media platform, so which used to hold the transformer winding. So it is a wire media or the protection against the transformer which used to wound the winding. That is the purpose of core. The second one is the transformer winding which used to take care of the flux production. So that's what the core and transformer. Actually, we have the other way also there. Only we need to discuss here the cross section view of the transformer construction. So that's what that is the way of the transformer core and as well as the transformer windings. Both parts only we need to consider. So in the complete construction details, we need to discuss about the each and every part in detail actually. But in our curriculum, only we need to discuss about the awareness regarding the construction details of the transformer. For that, we need to consider only the cross sectional view. In that, the transformer have consisting of mainly two parts, that is transformer core, other one is the transformer winding. So first let us go for the transformer core. So the transformer core is a media wire support to the transformer winding, so which would like to provide the low reluctance path to magnetic flux linkage. So this is the wire media to hold the transformer winding, and we would like to provide, and which would like to provide the magnetic flux linkage path for the low reluctance path for magnetic flux linkage, and also it provides the physical support to the transformer winding. That is the purpose of the core. So the core is a transformer core is a media wire platform to hold the transformer winding and also provide the physical support to the entire transformer, and as well as it would like to offer the low reluctance path. Low reluctance means which used to support the high magnetic flux linkage to in it. That's why it's called low reluctance path. So that is the purpose of the transformer core. So based on these reasons, the transformer core is made up of highly permeable material. That is highly permeable material. So that means we can make this one is with the help of the silicon laminated steel. So silicon laminated steel we have to use to make the core of the transformer. So the core of the transformer is designed with the help of this one, that is a E and I shapes only to close the entire things. So why should we prefer the laminated steel? Means we will like to reduce the core loss of the transformer. That's what we can prefer the laminated steel. So this is about the transformer core. The transformer core is a wire media the support to the transformer winding, and which would like to provide the low reluctance path to magnetic flux linkage. So based on this reason, we would like to make the transformer core with the help of the highly permeable material, that is a silicon steel. So that is about the core of the transformer. So next one, the winding of the transformer. The transformer winding is made up of the high grade copper material. So that we can say, so it is a set of copper turns wound over the transformer core. It is a set of the copper turns and wound over the transformer core is called transformer winding. So why should we prefer the transformer core winding as a copper material? Means, so the copper has the high conductivity and as well as the low resistance path. So that's what we can prefer the transformer winding as a high conductivity copper material. So then here there are the two kinds of the transformer windings are there. One is a primary winding, and second one is a secondary winding. So there are the two kinds of transformer windings are there. One is a primary winding, other one is a secondary winding. So the primary winding means, it is a set of the copper turns, so which would like to take the power supply, which would like to accept or feed the power supply is said to be primary winding. So then the secondary winding is also nothing but, so it is a set of copper turns which would like to supply the power to the load, or which would like to So given the power to the any kind of other networks or any other load, that's called secondary winding. So the conclusion point of this two means, if any of the set of turns are able to take the power supply as an input, that's what primary. Then alternate one is a secondary. So secondary, how can I say means, so whatever the winding side or whatever the set of coils are able to supply the power to the load or power to that corresponding load, so then it is called as secondary winding. So when we supply the power supply or connect the power supply to any coil, that's called primary. Then the any of the coil from the transformer winding to give the energy or power to the load, that's called secondary. So this is about the transformer winding. So the set of copper turns are wound over the transformer core is called transformer winding. So it is made up of the high grade copper material, that is high grade copper material, because which maintain the least resistance paths. So based on that, it will like to offer the low copper losses. That's what we can use the high grade copper material as a transformer winding. So there are the two kinds of transformer windings are there. One is a primary winding and as well as a secondary winding. So primary winding means it is a set of copper turns which would like to provide the, or which would like to connect to the, so power supply or power supply is taken means, that's called primary. So whatever the copper winding turns is able to supply the power to the load, that's called secondary. So this is the construction, basic construction or cross-sectional construction details of the single phase transformer. So this is enough for the basic engineering course. So the next topic of this session is, that is a working principle of the single phase transformer. So we have already discussed about the transformer means. So transformer is a static device. It transfers the electrical power from one circuit to another circuit without changing frequency in the magnetic media is called transformer. So the transformer is working under the principle of the mutual induction. So before going to involve into the mutual induction, then we would like to know about the self induction. Self induction means, so whenever the magnetic flux developed the coil, so which would like to links with the all the turns over the same coil. So according to the Faraday law of electromagnetic induction, an electromotive force gets induced. That's called self induction. So whatever the coil, so has to develop the own magnetic flux. So if it is linked to the all over, all the turns over the same coil, then that process is called simply self induction. So same coil flux links with the same coil all the turns, that's called self induction. Then the transformer is working under the principle of the mutual induction or Faraday's law of electromagnetic induction. So this is the principle of the single phase transformer. So the Faraday law of electromagnetic induction means, whenever the magnetic flux changes, so because of the instantaneous flux, or whenever the magnetic flux changes happen between the flux and the conductor, an electromotive force gets induced. So that's what the Faraday's law of electromagnetic induction. So there will be a there will be a change provided between the flux and the conductor. So we will get the electromotive force production in that particular conductor is said to be, so the Faraday law of electromagnetic induction. So the single phase transformer or any transformer is working under the principle of the Faraday law of electromagnetic induction or mutual induction. So both similar only. That's why it is working under the principle of the Faraday law of electromagnetic induction only. So whenever apply the instantaneous voltage, so this is the instantaneous voltage or instantaneous power. So whenever apply the instantaneous voltage to the any of the transformer winding which develop the instantaneous magnetic flux. So this is the instantaneous magnetic flux, or which develop the change in magnetic flux. So change in means it is a d phi by dt. So whenever the instantaneous magnetic voltage applied to the any of the transformer winding, so that's called primary winding. So that instantaneous voltage develop the instantaneous magnetic flux. The instantaneous magnetic flux initially links with the all the turns over the same coil. So according to the Faraday law of electromagnetic induction, an electromotive force gets induced. So that EMF is called self-induced EMF. This one is a self-induced EMF. So because the flux developed, produced by this coil only. So it is initially linked to the all the turns over the same coil. According to the induction process, we will get the electromotive force production in the same coil. That's called self-induction. So that's corresponding EMF is said to be the self-induced EMF. So this is the self-induction. But the transformer working under the principle of mutual induction means we have applied the alternating voltage or instantaneous voltage to the transformer winding, so which develop the instantaneous magnetic flux. It is initially linked to the all the turns over the same coil, so which transfer that EMF is created, that's called self-induced EMF. So it's also transferred uniformly to the entire core of the transformer. It's also easily transferred to the entire core of the transformer. Why? Because it's a magnetic material. That's what it's easily carry the magnetic flux throughout the entire material. So we have also wound over the transformer core as a other coil. So based on the so transferring capability of the magnetic flux, and also EMF gets created on gets developed on the other coil of the transformer. So this thing is called as a mutual induction. So the mutual induction of the transformer is nothing but, so whenever the instantaneous or alternating flux so transferred uniformly so to the entire core. So because it was created or it was given by this voltage, I mean this flux. So it was given by this flux only. So this instantaneous flux initially linked to this coil, and which will transfer the throughout the entire core of the transformer. And also there is a possibility to get the EMF on the secondary side, on this side of the winding, I mean this side of the transformer winding. So this whole process said to be simply mutual induction. So also there will be a Faraday's law of electromagnetic induction applicable here. So based on that, an electromotive force gets induced on this side. So that corresponding EMF is called so mutually induced EMF. So this whole process said to be mutual induction. Whenever the instantaneous or alternating flux transferred uniformly so throughout the entire transformer core, and also EMF gets induced on other coil side of the transformer winding. So this whole process said to be mutual induction. This corresponding EMF according to the Faraday's law of electromagnetic induction is called as a mutually induced EMF. So this whole process simply said to be mutual induction. So this is the principle behind the working of the transformer. So we have applied the electromotive force. We have applied the alternating voltage to the other one side of the transformer winding. So it will generate it will develop the some amount of flux, that is a alternating flux. So this alternating flux transferred to the entire core of the transformer, because core is a magnetic material. Based on that, we will get the flux transferring phenomena from the primary to secondary. One side to another side. So based on that, we will also get the some EMF production on the this coil of the transformer winding. So this whole process said to be simply the mutual induction. According to the mutual induction of the mutual induction process only, the transformer produces the electromotive force on the secondary winding of the transformer. That's called mutual induction, and that's corresponding EMF is said to be so mutually induced EMF. So this is the working principle behind the transformer. So that is, whenever applied the instantaneous or alternating voltage to any side of the transformer winding called primary, which develop the instantaneous or alternating flux, so which is initially links the all the turns over the same coil. According to the Faraday's law of electromagnetic induction, an EMF gets induced. That EMF is called self-induced EMF. That's we can say E1. And also there is a possibility the same flux. So whatever the flux developed in the primary side coil, which transferred the same flux towards the entire core of the transformer. So we have also wound the other set of the copper turns on the same transformer core other side. So there will be also possibility to get the electromotive force production on other coil side of the transformer according to Faraday. So that corresponding the EMF is simply called as the mutually induced EMF. So this one is called mutual induced EMF. So it is a mutually induced EMF. So the whole process said to be mutual induction process. The mutual induction is states that whenever the instantaneous or alternating flux transferred uniformly to the entire transformer, and also EMF gets induced on other coil or other winding of the transformer. So this whole process called simply mutual induction, and the corresponding EMF is said to be mutually induced EMF. So this is the working principle of the transformer. So also happen here through the animation, applied the voltage with the help of the alternator or AC voltage source, so which develop the instantaneous magnetic flux, and which is links to the entire transformer core with the help of the magnetic material. And we will also get the electromotive force production on the other coil of the transformer. Based on that, the bulb is lighting up continuously. That's what the mutual induction. So this is the end of the working principle of the transformer. So it's animation video clearly understand the concept of the mutual induction. So flux given by the alternating source which develop the alternating flux which transfer the alternating flux to the entire transformer, and also EMF generated by the transformer secondary winding because of the mutual induction or Faraday law of electromagnetic induction, so that we will get the lighting up the bulb continuously. So next, the summary of the session means, so till now we have discussed about the transformer introduction. So the transformer used everywhere to reduce and also the enhance the voltage level, to reduce the voltage level and as well as the enhance the voltage level. I mean increase the voltage level and as well as the decrease the voltage level. Based on the requirement, either we need to increase the voltage level, and based on the requirement we need to reduce the voltage level. So how can we get this instant means? So right now we are using the mobile phone chargers. So each and every mobile phone charger, I mean each and every mobile phone charger accept the least, less voltage only, because the batteries are going to consume the less voltage. That's what we need to use transformer to reduce the voltage level from the input side to output side. That's what we can use at reduce level. So for that we can use the transformer only to get the reduction of the voltage. So this is the transformer introduction, and the next one is we have discussed about the working principle, the construction details after that. So construction details. In the construction details, mainly we have the two kinds of constructions are there. The entire transformer construction, it is a big structure, and also the cross sectional view. In this module, we need to only cover about the cross sectional view of the transformer only. So in the cross sectional view of the transformer, it has mainly two parts. That is the transformer core. Other one is a transformer winding. So the transformer core is a media or wire platform to hold the transformer winding, which would like to provide the physical support to the transformer and also provide the offer the least reluctance path to magnetic flux linkage. So based on that, it would like to make the material as silicon laminated steel material. So there are the set of copper trans wound over the transformer core is called winding. So we have the two kinds of windings are there, that is a primary and secondary. So if it is taken the power supply, the set of copper trans is called primary. So the set of copper trans are able to supply the power to the load, that's called secondary. So this is the transformer construction details. We have already discussed so clearly in the same session. The next one is working principle. So the transformer is working under the principle of mutual induction. So it is working under the principle of simply mutual induction. So mutual induction means whenever the instantaneous or alternating flux transferred uniformly to the entire transformer core, and also EMF gets induced on the other set of copper turns of the transformer. So the whole process said to be mutual induction, and the corresponding EMF is called as mutually induced EMF. So these three things we have till now discussed in this session. In the next session, we are going to discuss about the electromotive force equation of the transformer, and after that types of transformer, and after that we need to cover the numerical based on the transformer. So thanks for watching. This is the end of the session, and thanks for watching. So thank you one and all.